we are asked here to find the x-coordinates of the tangent of any points on this particular curve where the tangent is, firstly, parallel to this, and secondly, perpendicular to that. So to understand this question, you need to understand that both of these words are referring to descriptions of gradient. Parallel means same gradient, and perpendicular is right angles to, but still to do with the gradient. Parallel to this line, so first we need to identify what the gradient of this line is. This is a linear function where we might have, say, something like y equals mx plus b. Here the gradient is 108. So we want something that there's the same gradient as 108. Perpendicular to this particular line, you may need to rearrange this so you can read the gradient straight off a linear function, so I'll do that as well. So I want to rearrange this to get a y equals minus x minus 6 divided by 12. So I can see here that the gradient of this line is minus 1/12. Perpendicular to this minus 1/12 will actually mean what we want is the negative reciprocal. Negative means we change the sign, and reciprocal means flip it upside down. So I'm going to have, for this one, the gradient of 12. So I've got 2 here. This one I want the gradient is the same as this line. I want it to be 108. Perpendicular to this line, I had to find out what the gradient of this line was. It was minus 1/12. Perpendicular to means find the negative reciprocal, which is 12. Still, both of these are talking about gradients. I need the gradient function now. So let's find the derivative of that particular function. Y dash is, using the chain rule because I've got a bracket and a power, 3 times 4x minus 7 to the power 2 times the derivative of the inside, which is 4. This is 12, 4x minus 7 squared. Now I want to find the x-coordinates of any points where this happens. So the x-coordinates where this happens, we're going to set now the derivative to be, in our first case, 108. I'm going to find out where the gradient is 108, and then that is where it is parallel to this line. So I have 108 equals 12 times 4x minus 7 squared. So I divide by 12. So this will be 9. Take the square root. Square roots can have positive or negative answers, so I'm going to have 2 cases where this happens. Now I can have where 3 equals 4x minus 7 and minus 3 equals 4x minus 7. So I'm going to have plus 7 is 10. 10 quarters is the first one. And on this side, plus 7 over there gives me 4 and 1. They're the x-coordinates where it is parallel to this function. That's the answer to that first part. Now continuing with the question over this side, we now want to find where it's perpendicular to that the line, so we want to set now the derivative equal to 12. So we have 12 equals 12 times 4x minus 7 squared. So we can do it the way we did before, split it up, or you might like to do it this way all in one. So I'm going to have 7 plus 1 is 8 over 4 is 2, or 7 minus 1 is 6 quarters. So these are the x-coordinates where it is perpendicular to this line that we had before.